monitoring. So I think last time Ivan bring some our beta technology as well as the manual sampling for you. So this is the slide he shared to you. At the left hand side, it's for the manual sampler. So it's the gravimetric. We weigh the filter before and after we collect the sample. And at the right hand side, we have the beta attenuation. Also within hybrid system, light scattering plus beta technology. So I think for these three technology I've already introduced to you. And today I will focus on this one, TEOM. Okay, so we have different model of TEOM. And let's say, what's TEOM mean? TEOM stands for tapered element oscillating microbalance. Actually, it's a microbalance. Okay, so it's like the manual sampling. We have a microbalance, and we put a filter on the microbalance. So it's the direct continuous measurement. So also it's NIST traceable. Okay, so we got the different certificate from different countries like US EPA, TUV from Europe, and CCP from China. Okay, so because of different configurations, so we have different models. Some model can measure PM 2.5 and PM 10 at the same time, and some model can measure the PM 2.5 plus the semi-volatile portion. So we can discuss in detail later. Okay, and this model we designed since 2005, and at that time, the panel is designed with touch screen, and the software is support with ePro, which is our standard software. Okay, so as you can see, 4 models, 1405. Okay, is the direct measurement by TEOM, and we can monitor total suspended particulate matter, and PM 10, PM 2.5, also PM 1. Okay, for the second model with D means die-cast system. So we can measure PM 2.5 and PM cross. PM cross means PM 10 minus PM 2.5. So the duration between 2.5 and 10, we call it PM cross. So we measure PM 2.5 and PM cross. Then we PM 2.5 plus PM cross, then we can get PM 10. Okay. And the third version is within F. F means there will be an additional filter dynamic measurement system we call FDMS. Means within this system, we can get the volatile and the non-volatile PM fractions. Okay. Same. DF means there's dual channels, and all with the FDMS system. Okay. So the product features, I think I just run through it, and the difference is the calculation of the real-time mass concentration. We use the 1 hour rolling average, means the minutes data is come from the past 60 data average, and we rolling calculating the average and update it every 6 minutes. Okay. And the filter is not as the one for beta. You can see the filter tab. And for beta, the sampling, manual sampling method is the 47 millimeter. And for TEOM, it's the smaller filter, 16 millimeter. Okay. Another, we will use the 47 millimeter diameter to collect the particles. And this is another use we'll discuss later. For the sampling condition, we have Nephium dryer to remove the moisture. Compared to beta, beta use the heating tube, and this one we use the Nephium dryer. Okay, and for TEOM, I think it's quite, because the technology is more direct measurement. So for the professors or the researchers, believe TEOM much more than the beta technology, because it's the direct measurement. Okay. So the measuring range 0 to 1 million microgram per cubic meters, and resolution is 0.1 microgram per cubic meters. Okay, for this one, we have the 1405DF. We got the FEM list on 3 part: PN10, PN cross, and PN 2.5. So I'll share this document to you. USB EPA always update this FEM designation from time to time. Once they have the new vendors, new suppliers apply this certificate. This not only for particular matter, but also for the gases. Okay, maybe I can share the document to you for your reference. Yeah, can you see?
Yes.
Yep. So actually, you can Google it, easily to find. So the version is up to today. It's the latest version, update last Q4. So during the designated reference and the equivalent method, USPA have a very clear state on different brand, on different species like TSP, PN10. They have a summary table. Let me check here. So you can see that PN 2.5, different brands. Or you can see
this document.
Pardon?
Could you send me this document?
Sure, no problem.
Yeah. Thank you.
So it's PN10, and for other gases, SO2, they also have the clear list on that. And for thermal, we have the 43I trace label and 43IQ. Okay, so that's I think the documentation is quite useful to tell the customer we got qualified by US EPA, although there's different brand, because for US EPA, they are quite flexible. If the supplier vendor apply the documentation followed by, let's say they have a guideline, the 40 CFR 50 appendix error. Once you can apply this, followed by the testing procedure, and after their review, they will issue the certificate to you. Okay. Okay, back to our presentation. Okay, so for TEOM, we discussed the technology. So we have two different models, 1405F and 1405DF. The main difference is that you can image for 1405F, it's a TEOM plus FDMS system. And for DF, it's two 1405F. So you can see there will be 2 dryer compared to 1405F and two TEOM inside the module. And the difference is they have the same PN10 inlet, but the size, how they cut the PN2.5 is slightly different. So this is the principle. We have the PN10 inlet here. After we collect the sample into this PN10 inlet, and there will be a sizer to it's a cyclone, okay, impactor or cyclone to cut all the particle size into less than PN2.5. Okay, so you can see this workflow: sample gas then goes through to the PN10 inlet and to this virtual impact, and then spray into the PN2.5 and the PN course, different tubes you can see here. Okay, fine. Fine particle means the PN2.5 and PN cross, the flow is different. Okay, when they goes, this is on the roof of the analyzer house. Okay, so goes now to the analyzer itself, and we zoom in. There will be 2 dryers to remove moisture. Okay, and then all the way to the TEOM. Okay, that's the flow path. Compared to 1405F, they also use the same PN10 inlet, which is the 16.7 liter per minute. Okay, and the different design is they have different bypass flow because different size using. Okay, so for this one, if we talk about PN 2.5 and PN10, this is the standard, almost the FEM method using currently. For PN10, it's the dynamic diameter at 50%. So the cut point always at the 16.67 liter per minute, and we got the PN10. After PN10, there is a cyclone. For PN2.5, it's called VSCC, very sharp cut cyclone. So as you can see, the sizer, the cut point is at the PN2.5 here. Okay, so why we choose VSCC? Because I think till now all the FEM analyzers pass this USCP FEM list. They always use the VSCC PN2.5 inlet. Okay, to size the PN2.5. And difference compared to 1405F and DF, they use the same inlet, but difference is the die-cut system, dual channel system. They use the virtual impactor. So virtual impactor is they have one inlet, although they have dual channels, but they have the same one inlet, and they use this virtual impactor to to separate the 2 particle size into 2 different air streams. Okay, one is for PN2.5 and another is for PN cross. So that's the difference, is the size difference. And after we size the PN2.5, then we will down this sample gas will go through to this Neptune dryer. Why we have the Neptune dryer here? Because we need to avoid on this process, the most challenging thing for particular measurement is how we remove the moisture properly. So as you can see, this aerodynamic size distribution. Actually, we want to monitor. Let me change my. Okay, we want to measure the PM2.5 peak as this shape. So, but unfortunately, in the real world, particle always attach the moisture, especially for, I think in Vietnam, also in Taiwan, it's quite humidity sometimes. So moisture will attach on the particle itself. Sometimes if we measure the whole compound, we may measure the water, H2O, so we can see the high concentration, but maybe most of them are moisture. But moisture for us is fine. We won't cause our health issue. But the number for Monterey, for Northern, is very bad because if the PM2.5 concentration is high, means public will know, people like you and me will feel the government doing nothing. Okay, so need to ensure the data is quite reflect to the real PM2.5 concentration. So the main topic is how we remove the moisture. Okay, so for beta, we use the heating tube. We have the kind of smart heater, dynamic heating tube, to remove the water. But if we set the heating overheat or not enough heating, you may get the wrong number. That's if we heat too much, then you will lose the left hand right side. But if we provide a lower temperature to heat, then you will measure including lots of waters. But for TEOM, for this 1405 F or DF, the difference is we don't use the heating way. We use this, it's the two-bond pattern. So it's a kind of physical way. When the sample gas pass through this dryer, it's a film. Okay, all the moisture outside of the particle will remove by this process. So it's quite useful to control the moisture. Sometimes in some SIMS application, if the moisture is high, we will provide a Nephium dryer, Nephium tube to control its moisture. Okay, so this one is the key for the TEOM. Okay, after we control the moisture, then we need to measure the real particle concentration. So again, it's the taper element microbalance. So filter is here. So the way we calculate how much mass concentration is by calculating the change of the frequency. Okay, so it's the formula. I think next slide, I think I ever showed to you. This one. So I think for this video introduced how the TEOM operate. Okay, so in the TEOM, in the 1405, you can see there's the microbalance on this chamber. Okay, and this is the filter, the 13mm filter. So you need to put the filter on this microbalance, the top of the microbalance. Okay, so you need to put the filter on here, this point. Okay, it's the way we have a tool. You can use, this is the spare filter. So you can use this tool to put the filter on the on the microbalance. Okay, so I pause here. Any questions? Okay, if no, I continue.
Yes, I have
Okay.
questions.
Okay, please.
So since TEOM was designed for continuous monitoring, and then you showed us the photos, we have to do a filter replacements. That means the operators or engineering has to go on site every 24 hours just to replace the filter.
No, because let's two concept. One is the loading capacity of this filter is 5 milligram. Okay, and under the normal ambient concentration, I think it's around maybe less than 50 microgram per cubic meter. So based on our experience, under the clean condition, maybe this filter can use, I think, lasting at least 2 or 3 months. So normally we will have an indicator show how many percentage of the loading on this filter. So normally we will observe this loading maybe more than 80 or 70%. And when you perform the maintenance, you just replace it, but not, we don't need to replace it every day.
So,
Okay.
is this easy to replace the filter?
I would say you need to have a bit experience on it, because you know the adapt here is quite small. So you must have a very skillful hand.
So we have to training for the client so they can do it.
Yes,
Yeah.
client
They
can
help
do by
themselves.
themselves. Yes.
Because as I know you said that although they do not to replace every day, but maybe
you once per
every
quarter.
month, every month they have to a quarter of month, a quarter of year, they have to replace the
Yeah.
filter. Okay.
Yes.
Mm.
But I
And
think it's quite easy to train, because when I first use it, since I was a university student, so you just maybe try one or twice, then you will know how to replace it.
and another problem is in Vietnam, you know, it's this season is very wet. It's very
Yep.
foggy. Yeah. So the humidity is very high. So it maybe affect a lot of this human, right?
Yep. I think if for the humidity, we normally for this dryer, we also have an indicator. Let's say if the dew point less than 4 degrees Celsius, then we need to replace this dryer. So normally 1 or 2 years, we will replace this dryer. But if the weather is quite humidity, then we may need to replace this dryer maybe every 6 or 9 months. So frankly speaking, for TEOM, the maintenance fee is higher than the beta technology. But for some research, they believe TEOM is better than technology, so they will evaluate which one they want to choose.
Yes. Okay.
Yeah. Okay, let's discuss the FDMS. So the main purpose of the FDMS is to measure the volatile or portion of the particle. Okay, because I'll back to this slide. Yep, this slide. So when we measure the PM 2.5, now PM 2.5 is a topic. So when we measure PM 2.5, sometimes we will face, even for the manual sample, when we wait, we collect the particle on the filter. We will condition it maybe 3 days, and you can see some loss of the volatile compounds during this procedure. Okay, so sometimes we cannot see the real PM 2.5 value. So the FDMS purpose is to measure this volatile compound. Okay, so that's it's the purpose of FDMS. Okay, so in this way we will have 2 models. One is for the base mass, okay, another is for the reference mass model. Okay, so I will show you what's the model works. So every 6 minutes, the switching valve here, when we PM 2.5, PM 10, after trial, there's a switching valve. For the base mass, it's baseline condition, so it's all the way to the TEOM. But if we switch after 6 minutes, we switch to the reference mode, and something change. So switch valve will direct this sample to this filter, 47 millimeter filter, and this filter will filter all the particle. Okay, means during this 6 minutes, for the TEOM itself, TEOM collect nothing, but it still vibrate, right? So when the 6 minute data will show if some volatile happens, you will see the frequency increased because the filter getting, I think, getting lighter than last 6 minutes. Okay, so we can see some loss on our measurement. Okay, so this loss, mass concentration loss, means the volatile compound of this particle. Okay, so it's the chiller, this filter. So after we switch to this chiller, all the particle will collect, filtered by this filter. And if we want to measure some composition, let's say heavy metal or VOC, of the particle, we can take this filter out and analyze it. Okay, so this is the base model. So sample just go down all the way to the TEOM. Okay, and this is the so-called reference model mode. So reference mode, it will go straight and switch here to this filter, maintain at 4 degrees Celsius. Okay, then goes to TEOM. Okay, then we'll have this calculation, the mass concentration. The real mass concentration means we will have the base mass concentration minus this reference mode. And because the reference mode, I think we always get the minus value, means minus plus become plus. So it will be a positive result for the real mass concentration. Okay, I pause here because when I first time touch the FDMS, it's quite easy to confuse at this point. Okay, but I think the way they just use the different mode to get the volatile content. Okay, so I think this photo can easily understand. So for the PM 2.5, sometimes for this particle we have the no volatile portion. We all have a semi-volatile portion. Okay, this is the theory PM 2.5. Okay, sometimes if we without FDMS, we may measure the real PM 2.5 at this kind of value. So this is the difference, the semi-volatile loss during the monitoring, or compared to the theory. And what FDMS do is to compensate this semi-volatile portion back. Okay. So as you can see, for some reading, if this is the reference in China, so we use TEOM. So we have the FDMS system. So we have the best concentration plus the reference concentration. Also, we have the PM10 TEOM without FDMS. So sometimes you can see if we compensate the volatile portion, the PM 2.5 concentration will more than PM10. Means actually the real measurement is underestimate because we missed the volatile portion. Okay. So that's the FDMS, how FDMS work. If you have any question, you can just raise your hand and we can discuss. So it's the resources we have, you can check on the internet. Yeah, so for the principal portion, I think you may understand how it works. Okay, and this one is when we apply the US EPA FEM certificate. Okay, we need to perform the test by ourselves and submit the report. Okay, and this one is performed by, I think it's by the New York EPB, means the New York Dongrui level. Okay, so they have different models. This is the last generation of TEOM. Okay, this is the current 1405DF. This is Ben. Ben is for the beta technology from May 1. Okay, and you know we have another beta annotation 5014I. Okay, they compare together. Okay, so on the roof you can see almost the PM10 inlet is the same, and the PM 2.5 always VSCC. Okay, and this 1405 DF is impactor. Okay, so this is the result. Because we need to for the continuous analyzers, we need to compare the result to the manual sampler. Okay. So and this one. So when you see the FRM, means it's the manual sampler. Okay, so we will have the this y plus x plus b. Okay, this formula, and you also need to check the R square value. Okay, and during this comparison, there's a criteria in US EPA. Means you need to check the slope, intercept, also correlation, and they have some different pairs bias test, deviation test. You need to pass. Then if the results you can fall into this block, that means you pass the test. So during this one, we passed the test for 5014I as well as the 1405DF. Actually, I think on the list of the USCP FEM list, you need to pass this one and gonna to get this certificate. Okay, that's all for the TEOM introduction. Do you have any questions?
Yes.
Okay, Evan, go ahead, please.
Can you go back to the slide where the FDMS is? Yes,
Yeah.
right here. Okay. So when you say for the base models, the sample will flow into the TEOM, the balance.
Yes.
And then we will, after 6 minutes, we will switch to the reference mass. For
Yes.
reference mass, the sample gas will go through this conditional sections, filter conditional
Yes.
section, and it
Yes.
has a filter.
Yes.
Does that mean all the filter will collect the PM10? And then
No,
the balance
PM2, PM2.5. I think all the particle will be collected.
Okay.
Because you already passed the sizer, right?
Yes. So during this time, the microbalance was still vibrating.
Yes.
And then after the 6 minutes, because the volatiles disappear, and then the frequency of the balance will change.
Yes.
And then we will know the amount of volatile compounds that is evaporate.
Correct. Yes.
And then we will switch back to the base model again.
Yes.
Okay.
But another important thing is about the algorithm, because we use the rolling average.
Yes.
60 minutes rolling average. So we can see the updated mini data every 6 minutes. Means for the 6 duration, mini 1, 2, 3, 4, 5, 6, the amount should be the same.
Okay.
Yep. So it's just data outputs. But for US EPA, normally they concern about the daily average data, because when we compare to FRM, FRM only can provide the daily data because the resolution is not enough for hourly, even half day, 12 hours.
Understand.
Okay. Yeah. Any other questions?
Can you show me the slide number 27?
7. Wow, so precise. Okay. Here.
Yeah. So I want to know 8,500 plus C. What is that?
This is actually, you can see the brand is RP. RP is the former TEOM inventor. let's say Thermo Fisher acquire IMP, so they design the TEOM. Okay, but Thermo Fisher acquire them and invent our own analyzer called 1405 DF. So some design changed. Let's say Nephion dryer. In this 8500 model, the dryer is not a film form. It's a tube form. But for the microbalance design, almost the same. Okay, so it's the last generation of TEOM.
That is not the product of Thermo, right?
Some acquire this one, but this one is already discontinued. Okay.
This TOM, is there in you have any client in Vietnam? That's they are using this TOM in Vietnam. No?
I think so, but I need to check I can check the install base for you. Because especially for the researcher, they like TEOM. Okay, I can check our customer list in Vietnam for you.
As I know one various institute of environment and technology in Vietnam, they have the TOM. This maybe I think this 1405 DF.
Okay. So you ever saw this before?
Yeah, I just know that they are using this device, but I don't know.
Don't worry, I'll check our customer list and share to you.
And can you show me the table for comparison between the TOM, bit rate attenuation, the accuracy of Z5 compare?
Yes, but I think the accuracy is because it will vary because different location, different weather, you will get different results. That's the challenge for TEOM. But I think for this one, the slide Ivan shared to you last time, I think there's a quite clear comparison. You can see my screen, right?
Yeah.
Yeah, it's the summary, but it's the characteristic.
Yeah, I know. But
what kind of comparison table you want?
Yeah, because this is this slide just shows the more accurate, just not the number. What I want is the number of the accuracy of this device, right?
Okay. I may come out some send some report to you like this one, made one, bam.
Because I saw in Thermo Fisher website, the accuracy of TOM it's the source is 0.75%.
Okay. You mean TEOM, right? Okay.
Yeah,
I can check
TEOM.
it right now. TEOM 1405. Let's say F. F accuracy. Precision, accuracy. Okay, here. Accuracy for mass measurement is plus minus 0.75%. Okay, and if we check with the 15 I say 1520 AI. Because now no same use this one, so I use this one. Accuracy for measurement. Okay, if 5% using this triple set. So looks like TEOM is more accurate. You mean the difference here?
Yeah.
Yeah, that's why TEOM is more. I think it's more close to the real data, real situation, because it's direct measurement compared to beta annotation. We use the carbon 14 source, okay, and we calculate the mass concentration by the difference of the source annotation. Okay, so it's different concept.
Yeah, because we need to explain for our customer.
Okay.
How when we use a TEOM or when we use bitrate, that's they can choose. That's the correct
Okay.
The device for their application.
Okay. No problem. So because TEOM direct measurement, so we'll have better accuracy. I think that's the best saying. Okay.
In fact, until now the TEOM is the best technology for the particle measurement, right?
Yes.
Yes. Okay. But how is the price? You know?
For 1405 F is around, I think it's 35,000 USD.
The more expensive, right?
Yes.
Okay.
And 1405 DF may additional 10,000. So rough number, we can check the price for you. But I can type here. Let me check. Okay. 1405 I think it's 5014i. I think it's close to 30K, around 25K. And 1405F 40. This 35,000. Slight difference. But the price is roughly there. I need to check in detail, but roughly there.
Yes. Okay. Thank you, Jason.
No problem. Right. Any other questions? Actually, I don't. I prepare enough slide, but maybe we'll have next training I can share to you, because addition on this TEOM, we use TEOM technology into the stack, and for the stack monitoring, it's more related to the industrial. Okay, so maybe next time I will share to you. We may find another time. So I will check the how US EPA control set up the regulation, because their regulation is mainly for the mercury here, mercury and air taxi standard mass regulation. And during this regulation, there will be two parameters need to monitor. One is mercury, another is particulate matter. Why? Because actually for those air toxic gases, they mainly focus on the heavy metal. But for heavy metal from the stack, it's very hard to measure because so far I think no commercialized heavy metal analyzers for the stack monitoring because the detection minimum is very high. Very low, very low. So USPA can use the PM concentration to estimate the heavy metal emission level. So that's the key concept. So during the session, I can share what the mass regulation say and some key compounds they concern and what solution some officials have. So we have the light scattering bundle TEOM and come out a very good precise precision and accuracy model. Okay, and what kind of result we have compared to the opacity. Okay. Also, I'll share mercury. We have quite good mercury analyzer in the world. So share some install base. And I think most important thing is in the US, we take the majority, more than 70% share because of we have the advanced technology. Yeah. Okay. Just share maybe for next training. All right. Any other questions?
This is very necessary for do because our client mainly from the thermal power plant, they have a lot of and steel plant and cement plant. They has a lot of they use a lot of kind of PM for the ECMS.
Yep.
Yeah.
So like in Taiwan, we do see the cement, steel, or thermal power plant. Yeah. They already install mercury and PM SIMS.
Yeah.
Yep. So I think that could be next target we can pursue the opportunities.
Okay.
Yeah. Okay.
Yes.
Then any other questions, Ivan or Han?
For the pricing, yes. The price you wrote down is correct. I just checked. It's roughly there. Yeah.
Still remember the price. Okay. Good. So I'll share the slide to you, Mr. Long and Ivan.
It's Vietnam's client. They care most about the price.
No, everybody cares about price.
Yeah. Okay.
Yeah. But I think for the CAE standpoint, because you have your, I think, third-party position, so you can choose the more accurate analyzer to recommend to the customer. So they may buy in, but maybe in the end, there's some price difference. We are not the lowest price provider, but we have certain advantages. Then within, I think, reasonable price range, a bit expensive, but I think the customer can accept it.
Yeah,
so show your charming.
That's why our duty is convince the client how to choose the right analyzer. But we have to show which is the advantage and disadvantage of every product to compare.
Okay.
And
sure.
As you know, as you said, that the price not the most parameter for the client to choose, but it depends on their design. So we need to show more about the price, the cost for operation a year, right?
Yes, that's sell the value.
Yeah, just it more meaningful for the customer, because that when the analyzer easy to maintain and calibrate, and the price for the spare part is cheaper than the other. Maybe it's easy to decide to choose the more expensive the analyzer, you know?
Yeah, I think so. If I were the customer, yes, I definitely will choose the cheaper one with the cheaper spare parts.
Yeah.
Totally understand. Okay, maybe next time if you identify the potential customer, they're really interested in our solution, just let Ivan and Han or me know, and we can arrange the customer visit with you to deliver our advantage or share our experience to them.
Yeah, sure.
Yeah, good.
Thank you. Thank you, Kason.
Okay.
Thank you, Ivan. And
Yeah,
thank you,
so
everyone.
we can end the call. Okay, thank you.
Yeah, thank you.
Thank you. Thank you. Bye bye.
See you. Bye bye.
You.